Alright everybody, we'll do another update today, and this one will be relatively short because of how late it is coming out, but nonetheless I want to take the chances to do an update on today's severe weather outlook. In fact, we should be going here. So today we do also have an enhanced risk, and we have what has now been upgraded to a bit of a northern extent, and a lot of the talks are now about the northern extent because that's where the potential holistic tracks that show the most likely scenario for the highest tornado potential in this setup, and so that is most in question. The tornado risk is, however, slightly to the south, but it's still in a broad risk within northeastern Louisiana, southeastern Arkansas, most of Mississippi except the southern part, and then western Alabama. We got some of these unhatched parts, but this also has a probability, and most of 5% will be covered through QLCS types. But ultimately, again, there is a probability that this could outperform, especially in this region up here, where it will track along the surface flow pattern, enhanced and very similar to how certain long track supercells like the Mayfield in 2021 and maybe even Yazoo City. Some of those types of tornadoes ran along the surface low pattern, along that, and in the open warm sector, and then essentially grew and from birth to death within the same span, like the same favourable warm sector period in which the surface flow tracked over just to the south. And so yeah, very similar type of setup. We also have a wind risk. It's 45% now. It's been upgraded, but there is no hatch. It could have went moderate, this risk, mainly for wind. So it looks like the wind risk will become a pretty strong linear QLCS, although this QLCS will probably be more northeast to southwest oriented, but still nonetheless it will probably bow out at this point, which means that it will have a sort of re-inflow surge that will cause it like a little bit of an arc shape, like if you were to observe from a radar perspective. That'll probably mean very high winds, probably over 75 miles per hour for the very severe gusts. And so yeah, it can definitely be possible to do that. But also just general considerable severe thunderstorm risks can also occur with high winds in this 45% and with higher chance. And then hail risk is fairly minimal now. So with that the synopsis we're just going to go straight to. So again, water vapor imagery shows potent mid-level trough over the Permian Basin, pivoting east through the base of a larger scale trough forecast to shift from the Rockies east to Mississippi Valley. Complex surface pattern is evident with a low over Oklahoma, accompanying a trailing cold front, maritime residual frontal zone, drift of East Texas, arcing northeastward into Mississippi, Arkansas, Tennessee border region, and southeastward into the northeast of the Gulf. And then we have the cyclone consolidates and moves eastwards in Arkansas, and then the composite boundary and the north, and it will advance northward with the warm front into the mid-south and the Appalachians. And then we have that the forecast is to push southeast and overtake the western portion of the warm sector late today and tonight, and then we'll see some score lines. And then roughly the same sort of talk will be here. We have the certain mentions of the certain things that we say, and then we'll see the modest lapse rates. It does mention certain things: damaging wind risk, late tornado risk with low level jet to increase. So now we can just observe this pattern ourselves very quickly as well. Alright, so we will observe this pattern ourselves. So temperature map, we're just going to look at this fairly high temperature distribution in the south, especially on that marine, the marine and the synoptic front, warm front, and that's open warm sector. That will be the providing for where the highest temperatures will overlap the highest dew points, and that's where the strongest updrafts will be. So we're going to be seeing by 1800 21Z warming on that, and then we start seeing some of these pressure tongues pretty elongated, but we do start seeing it by 0Z a little bit of a surface low pattern here, and this pattern can clearly be evident through this with this sort of cold front latching down here, and we see some northerlies, we see some southerlies, so strong warm advection backed flow all the way up to this with the synoptics warm sector going very northeast tilted, so that means very large warm sector, and that will include that new favorability zone up here. Fairly low temperatures shown here by a NAM sort of biased computer model generation, and that will prevent, like, that will not show the highest possible values, but the lower averages instead. But then we'll see the overall pattern is pretty much favorable, and this also does look very similar to the year before last year, in 24th March 2023, with that sort of setup along the Mississippi Valley. And often when you see a different differential in the topography, you can often see a change in the supercellular behavior. If one is to initiate and progress across the valley, it will cause topographical effects, and that can affect the geostrophic and the agiostrophy of the hodograph. So it's essentially the way the terrain can affect the hodographs, improve that wind profile, and allow that certain things like surface flow, like inflow ingestion, and allow for better tornado genesis in that sense. Dew points are represented in the same way. We see this with the strongest, the best dew points up here along the boundary, and then we see quite a broad sector, 64 dew points, which is a moderate to high, and then we see it go to a very northern extent here, and it does have a fairly fast moving cold front, and the boundary is kind of oriented in this way as well. So if any supercell is to move across this way, it could latch off the surface vorticity along that warm front. At the same time, there could be again a conglomeration of updrafts running into each other, and that merging and that joining process will create more of a linear QLCS immediately. That could result in the reduction in the supercellular thread. But very similar to the last discussion we did, with a very similar type of setup in the same region, and it did come into fruition with the sort of things I mentioned with that QLCS, but then certain tornado risks, especially eastwards. So a lot of the tornado risk actually happened in the exiting zone and the unexpected area around here, where we saw 2 PDS tornado risks, and then we saw a couple of QLCS tornadoes and a broad general movement. And so we did see a couple of, not very much, but again we could see that sort of thing up here with a couple of enhanced tornadic risks up here. We could probably see an enhanced vorticity and ML Cape overlap here, and that could be that could be one large generalized way to increase the threat. But there also could be micro scale level ways that could enhance the tornado risk in this area up here. So this could be a particular area to watch if a supercell does track through this region, or even a QLCS embedded supercell, or even QLCS tornadoes sometimes can be really potent if it's in the correct favorability. And normally you want to see that north-south orientation. If it is a QLCS tornado, that does become a significant tornado. That's often how they get PDS become significant. So I think we're just going to take a sounding almost straight away. So we're going to do up here as well, where in Tennessee it is being talked about a lot. Okay, so further south, yeah. So the Cape again is on the minimal side as is expected. We're seeing about 1,000, but it's still on the minimum. It's on because of the temperature bias, this instability can increase, and there is a bit of clearing that will be shown. In fact, we probably show it in a second here, but. So we got instability that could be over 1,000, so that would be enough for the drafts to at least grow. There are certain things that need to be watched out with this. We do have a decent amount of three capes, so that does mean a lot of this instability is focused on that lowest 3 kilometers, and that will enhance that vorticity, stretching, tilting, and production of tornado genesis. Often, even if in a sapped profile like this, 3 cape can provide for large tornadoes, large condensation of larger tornadoes. It may be broad, weak, but still it can enhance that vorticity quickly, and probably can allow for rapidly intensifying supercells and rapid condensation of tornadoes if we have that 3 cape, and it actually does come into fruition where we see that vorticity stretching overlap with a wind profile like this. But one thing I wanted to just say was a little bit of the saturation up here, and we see a little bit of this weak upper level instability. Maybe sometimes it's realized that these can sap the overall instability values, and also sometimes it can be high level cloud cover, and also sometimes as well you want that strong healthy updrafts to push the ecotops all the way into the troposphere, And without that, maybe sometimes if that strong updraft growth is prevented through certain things like saturation or just not enough cape here, that could potentially be a factor. It's not as clear whether that is true or not, but that is something that is a little bit, it's possible, because sometimes you have a perfect sort of sounding where you have a perfect inversion and you see a perfect sort of thick instability in the mid levels and the upper levels that go all the way up, and you see that sometimes can be important for the overall health of that supercell. And then the wind profile, I can see that it's going to be very significant, and there is a lot of speed share and wind direction, more speed share, particularly between the 1000 to 850 millibars, so a low level jet region, which will only increase because of the low level jet increasing with time overnight. And that low level jet, when there is less of that surface temperature cooling, you have that enhanced laminar flow that will allow for the low level jet to increase, and you see a stronger jet max. And so again, we have high bulk shear values for allowing for strong healthy updrafts. If they were to maintain and grow, that will be very clear by here. And then we do have a decent perpendicularity, I believe. So I believe if we do come back with some sort of wind vector, we should see, yeah, I mean, it's fairly decent in this region, but there is a little bit of this idea that it could be slightly more linear, I mean parallel, sorry, because of the wind vector becoming more southwesterly here with the trailing cold front, and that can allow for a lot of merging and destructive interference that could harm the tornado risk. And then overall, we have a decent profile though, especially on the wind side. And streamlined vorticity currents is something that I never really mentioned, but we see that if you go from the inflow vectors and then you put a perpendicular vector off that horizontal vorticity, you will see here that it will be this is the inflow vector, and then you see about here. So there's about a pretty good, I would say over 75% streamwise vorticityness and streamwiseness. So that will probably allow for decent low level vorticity stretching as well. So not just the overall whole graph, but the lowest levels, and the streamwise vorticity currents aiding in that tornadic genesis will be enhanced likely. And again, the same thing is represented here, except here we'll see a lot more instability in fact. So there's quite a large gradient. This could actually imply that there could be a thermal sort of boundary like that will occur because of the temperature differential, because we have a clearly different we have different instability values by quite a large margin. So that could be some sort of boundary that could enhance tornadic genesis, if a supercell were to track over it. And we can also see that everything else represents pretty much the same, and this is slightly more east, I believe, as well. So yeah, so if it's more east, then this boundary as supercells, because if a supercell was to persist from the northeastern Louisiana and track into northern Mississippi, over the time, the convective evolution of that supercell may change so much so that it may not provide a healthy enough updrafts or mesocyclones to allow for strong tornado genesis. And we often see that tornado potential and enhanced vorticity and spin with the mesocyclone and the upper levels, but you don't see it come down to the surface levels. And should that happen, where it becomes a negative convective evolution for the supercell, then if there is some sort of differential heating boundary or some sort of way to affect that mesocyclone in the upper levels to bring down to surface levels, this could be it. And this instability could also be what is enough for the strongest and healthiest updrafts that do grow and become more apparent in the open warm sector if they were to initiate in this area. And then we also see the same thing here with lower instability, but we see the very high shear environment, a lot of SRH and effective inflow. The large supercells definitely can occur. And we do have a veer profile here, but we also see that shunting of the good ventilation type of outflow upper level outflow with the supercell, which means that they could be healthy and allow for well, not necessarily multiple cyclic mesocyclogenesis, but we can see a strong healthy updraft persist for a long period of time, and single mesocyclone able to produce multiple tornadoes even, and if that is to allow for that, because if it were to veer back towards it, the outflow back towards the supercell region, then that precipitation may wrap around effect, and the sort of intrusions and any sort of cold air infections or any sort of type of thing that would affect the macroscale vorticity and stretching and the ability for the mesocyclone to rotate would be affected significantly. But here it looks pretty healthy and allowing for healthy updrafts. And I think all is to be said so far. So I think that this superstellar outbreak is clearly got some potency. There is a lot of QLCS sort of projection, and I understand that completely with the way it's demonstrated. In fact, with the HRRR demonstrating, it was having a bias with a lot of QLCS formation earlier, and we still see that as well. So, but then we see a lot of ideas of, instead of an prefrontal supercellular open normal sector type, we see a lot of embedded and strong QLCS type. But that will often come with this further south, especially when you have a better orientation. But it is in question, because with the greenfield outbreak as well, sometimes when you have a bit of an overlap with these supercells, sometimes you can have sort of mergers and embedded supercells that can really be enhanced by any sort of localized cold pool of vorticity stretching, horizontal vorticity zones within that, and that could cause very microscale sort of enhanced tornadogenesis within that line as well. So it can be watched out, and it could be significant, especially in the northern side up here, even if it's with a QLCS type. But yeah, they're very difficult to see as well if that was to go. Last thing is that this is the evolution. Currently, there's not many supercells in this satellite imagery or any sort of convection. We see a lot of bubbling cumulus here, but then we also see these striations, and these striations are the confluence boundaries, and we can see that generally there's quite a few of them here, and some of these in particular that are kind of orientated in the little anticyclonic motion. Rigtimer pointed this out, and I just want to credit that to him completely, but I was just interested in mentioning it because I'm not sure, there is not much any research really on the orientations of confluence boundaries, but if it were to affect it in any sort of way, potentially it could it could affect the ability for supercells to become right movers and allow for that tornadogenesis process, and affect it in a negative way essentially, but also can allow for mergers, and should that merging happen, it could allow for constructive interference and a stronger a higher probability of tornadogenesis. But again, the overall idea is that the confluence boundaries will allow for supercellular formation, and they will persist within this open normal sector. And if they do actually form more than the models demonstrate, then they will take advantage of the instability in that shear already present, and then they will grow into the northern sector. We see that sort of cloud cover here is to move away, so it is okay currently, but a lot of clearing in this large broad sector, a lot more than I believe could have been anticipated. So again, the instability values could be greater as well. And I think with that, everything I can really think of that I wanted to say, yeah, it's overall a decent pattern, likely could represent more like a moderate risk type should it be like that, or it could be a situation where we see a huge QLCS, but then we see some sort of situation like with Huntsville in like 1989, or like even last year with Barnsdale, a large QLCS but a single supercell able to take advantage, and a sort of nudging effect between the QLCS and the supercell. That could occur up here or anywhere across the line should it occur. These are things to watch out, and I'll see you guys in the next update.